Welcome to Chapter 7, Section 1, Triangle Application Theorems. In this section, we're going to apply theorems about the interior angles, the exterior angles, and the midlines of triangles. And we're going to nail down exactly what those three terms mean. So first off, we're going to look at theorem number 50, which states that the sum of the measure of three angles of a triangle is 180. And you know this. You've seen it before, and we've actually used this in the past in finding a third angle that we don't know from a triangle, knowing that the sum is always going to be 180. But just another way to look at it to prove it, if we had a triangle here and I drew a line that's parallel to the base of this triangle, well, we can say that, let's say we call this angle 1 right here. Well, this angle is going to be congruent to this angle because they are alternate interior angles if these two lines are parallel. And this angle right here is going to be congruent to this angle, so let's call that angle 2. And then we've got angle 3 right here. Well, if you look, angle 1, 2, and 3, well, they form a straight angle. So you know the sum of angle 1, 2, and 3, their measures have to equal 180. So therefore, that's just a nice, quick little back-of-the-envelope proof for this theorem, theorem number 50. Now, to understand theorem 51, we have to talk about what an exterior angle is. And an exterior angle is the angle that is adjacent and supplementary to an interior angle of a polygon. Now, a few key things here. First off, this works for any polygon. So it can be a triangle, it can be a rectangle, it could be a hexagon. It doesn't matter. Any polygon that we have, no matter the sides, there are always exterior angles. And what we mean by an exterior angle is it has to be adjacent, which, remember that word, adjacent means next to, and supplementary. So the angle has to form a straight angle when it is combined with its interior angle. So if you look at this diagram here, we have triangle ABC. Well, this angle in here is an interior angle, the angle at C, ACB. And the exterior angle to that is just extending the segment AC and measuring the angle of the outside. All right, it's supplementary and adjacent to the angle ACB, so that's the exterior angle. All right, so where does this come into play? Well, theorem 51 tells us that the measure of an exterior angle is equal to the sum of the measures of the remote interior angle. So we've got another key word in here, something that's a little new. Well, what does that mean by remote interior angles? Well, these angles right here, angle A and angle B, are the remote interior angles to this angle. Let's call it angle 2. Okay, so angle 2 is the exterior angle. Angle B and angle A are the remote interior angles. So what this is telling us here is that in a triangle, and this is important, it's got to be in a triangle, the exterior angle is just equal to the sum of the other two. Now, let's make sense of this. We can actually prove this using the theorem number 50, saying that, well, we know angle at A, angle at B, and angle at C, all those three angles inside the triangle have to add up to 180, right? Well, this angle at C is supplementary to angle 2, so C plus whatever angle 2 is has to equal 180. Well, A and B, if we add that to C, that also equals 180, so 2 has to equal whatever the sum of A and B is. So once again, that's just a quick little proof, not a formal proof, but just a rationalization of why Theorem 51 makes sense. Now, Theorem 52, we're talking about a new thing, a new property of a triangle called a midline. All right, now, well, let's just see Theorem 52. It says a segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is 1/2 the length of the third side. Okay, so a lot of stuff going on here in this theorem. And we give this theorem a title. We call it the midline theorem. But what's important here is that if we have a segment that joins the midpoints, okay, if we join the midpoints, so if I tell you that D is the midpoint of AC and E is the midpoint of AB, and we join those two midpoints, well, this is what's going to happen. This DE is going to be parallel to CB. All right? And DE is going to be half of CB. So the length of DE is going to be 1/2 the length of this third side CB. Okay? So right away, if we have a triangle and we join two midpoints, we can conclude. We want to think about, well, what does that give us? What can we conclude from being given that DE is a midline? So I could tell you one of two things. I could tell you D is a midpoint of AC, E is the midpoint of AB, or I could say that DE is a midline. All right, and from that, what can we conclude? Well, this theorem tells us that, well, right away we can conclude that DE is parallel to CB. Okay, so this is what we can conclude. And that looks like an M, but it's an N. All right, so we can conclude that DE is parallel to CB. We can conclude that the measure of CB is equal to twice the measure of DE. Now, you might ask, well, wait a minute. It says 1/2 in the theorem, but I'm using 2. Well, this is the same thing. DE is half of CB, so we could rewrite that to say DE is 1/2 times CB, or we could say CB is 2 times DE. Now, these are the two direct conclusions that we can make using Theorem 52, but there are some indirect conclusions that we can make as well using our parallel theorems that we had from Chapter 5. So knowing that DE is parallel to CB, well, we can start making some conclusions about angles. We can say that this angle right here is congruent to this angle. All right, so we can say angle ADE is congruent to angle ACB. Why? Well, that's because of corresponding angles. So through the PCA theorem, we can say those angles are congruent. Well, the same rationale can tell us that these angles right here are congruent. So we know angle B is congruent to angle AED. Come on. There we go. Okay, so right away, given a midline, we can conclude a lot of information. So knowing that D and E are midpoints or that DE is a midline, we can conclude all this stuff right here, all this stuff. Okay, and then from there we can make conclusions about triangles and all that, prove triangles congruent or even isosceles depending on other initial conditions. Okay, so we're going to take a look at number 2 on page 298. And in this diagram, we have lots of angles. We have 7 different angles depicted for us. There are more angles in the picture, but we have 7 of them labeled. Okay, and we're told that angle 1 is 130 degrees. So this is 130 degrees. And we're also told that angle 7 is 70 degrees. So this is 70. And we need to find the measure of angle 2, 3, 4, 5, and 6. So we want to know what is the measure of angle 2, what is the measure of angle 3, what is the measure of angle 4, what is the measure of angle 5, and what is the measure of angle 6. So using the theorems that we just discussed, we can find each of these angles. Well, first off, let's do the easy one. Angle 2, if this is 130, well, angle 2 is a supplement to angle 1. So that means that angle 2 has to be 50 degrees. Okay, well, if this is 50 degrees, we can take a look at angle 5 and angle 7. We know that they're vertical angles, so angle 5 has to be the same as 7, so that's 70 degrees. Okay, so angle 5, 70 degrees. Now, we can look at angle 6 to be a supplement of either angle 7 or angle 5. It doesn't matter. We can choose whichever angle we like. They're both 70. And either way, knowing that 6 is a supplement to an angle that's 70 degrees, we know that angle 6 has to be 110 degrees. Okay, well, let's use our theorem about exterior angles. So we have an exterior angle of 130 degrees, so that means it has to be equal to the sum of the two remote interior angles. So angle 1 has to equal the sum of angle 5 and angle 3. So 70 degrees plus some unknown angle 3 has to equal 130. Well, that means that unknown angle 3 has to be 60 degrees. So let's just double check to make sure that that works. And how can we double check that? Well, let's add 60, 70, and 50. If we add those together, we get 180, which means the interior of an angle, or excuse me, the sum of the interior angles of a triangle is 180, so we're good to go. We can also confirm by seeing that, well, 6 is our exterior angle at this angle up here, and that's 110 degrees, so it should equal the sum of the two remote interior angles. 60 plus 50 is 110. So let's go ahead and round this off and find our last angle, angle 4. Well, angle 4 is the supplement to angle 3, or angle 4 is the exterior angle that has to equal the sum of the two remote interior angles, angles 2 and 5. And either way, we get angle 4 to be 120 degrees. Okay, if you look over on the next page, on page 299, we have number 8. And in number 8, we're given the diagram as marked, and the diagram marked tells us that, well, angle F is a 90-degree angle, and angle K is a 70-degree angle. So right away, before we even look at any other given information, what can we conclude? Well, we can conclude that this has to be 20 degrees. Angle H, and you might ask, well, why can that be 20 degrees? Well, 90 plus 70 plus 20 has to equal 180, so that gives us the sum of our interior angles of a triangle. All right, well, what else is given to us? Well, we're also given that G is a midpoint and J is a midpoint. So what does that tell us about GJ? Well, GJ is a midline. So if GJ is a midline, we can conclude all those things that we talked about a few slides ago. So this is congruent to this. This is congruent to this. But more importantly, what do we know about these two segments, FK and GJ? They are parallel. So if they're parallel, we have corresponding angles that are congruent. So if the angle at F is 90 degrees, the angle at G right here is also 90 degrees. So one of the things we need to find, what's the measure of HGJ? Well, the measure of the angle HGJ has to equal 90 degrees because it's a right angle, corresponding angle to a right angle, so it's also right. Well, we also want to find the angle of HJG. So the measure of angle HJG, that is a corresponding angle to the 70-degree angle, so that's also 70 degrees. And then the final thing we want to find is the measure of angle H, which we already found right at the beginning to be 20 degrees. Okay, that's about does it for chapter 7, section 1. And in class on Monday, you're going to work on a couple practice problems, work some of this stuff out. If you want to try to take a look at some problems on page 298, 299, any of the problems on those two pages can give you a good representation of this section. Give those problems a shot before you come into class, and we'll work on that stuff in class and get all your questions answered.